Welcome back to the channel. Today we will start with Applied Physics 1 Numerical. Our problem 1 says that we are having two waves of wavelength 600 nanometer constructively interfered, and we have to find the minimum path difference between them. And we know the minimum path difference for constructive interference, that is delta x equals n lambda, where n is an integer and lambda is the wavelength. Minimum part difference for constructive interference corresponds to n equals 1. Now, when n is 1, delta x becomes equals to lambda, which is equals to 600 nanometer. And if you want to convert into meters, then it will be 6 multiplied by 10 to the power 9 meters. So the minimum part difference comes out to be 600 nanometer, which implies that our delta x is equal to 600 nanometer. Our next question is that there are two waves with wavelengths 500 nanometers and 700 nanometers interfere destructively, and we have to find the minimum path difference between the two waves. For destructive interference, the part difference delta x is equal to n half whole multiplied by lambda. The minimum path difference occurs when n equals 0. After this, our delta x becomes equals to lambda by 2, which is further equal to the sum of the wavelengths of the two given waves divided by 2, that is 500 plus 700 divided by 2, which is equals to 1200 divided by 2, which gives us our final answer as 600 nanometer. So the minimum part difference for two waves in destructive interference will be equal to 600 nanometer. Our next problem says that we have two monochromatic light waves with wavelengths of 550 nanometers and 650 nanometers, and we have to find the angular separation between two successive maxima. For constructive interference, angular separation, that is theta, is equals to lambda divided by d, where d is the slit separation. Then for two successive maximas, the path difference will be equal to m multiplied by lambda, where m is the integer representing order of the maxima. Now, let's calculate the value for angular separation, that is theta, for both the waves. Lambda 1 is 500 nanometers converted into meters. For calculating theta 1, divide the wavelength by slit separation distance, 0.3 multiplied by 10 to the power minus 3, which equals to 1.83 into 10 to the power minus 3 radians. Similarly, follow with lambda 2. For calculating theta 2, divide the wavelength by slit separation distance. This will be equal to 2.17 into 10 to the power minus 3 radians, correcting the theta 1 value. Angular separation between two maximas, that is delta theta, will be equal to theta 2 minus theta 1. That is 2.17 into 10 to the power of negative 3 minus 1.83 into 10 to the power of negative 3, which will be equal to 0.34 into 10 to the power 3 radians. That's it for today's video. We will look at other numerical problems in the next video. Do subscribe to the channel and like the video.